Okay, right. Thank you to Paul for inviting me this afternoon. So SuDS and water quality. I have to admit, I have got a vested interest in SuDS and water quality. I do a lot of open water swimming, and I like to swim in nice, pristine water. I've also got first-hand experience of swimming in the Thames and what happens when you swallow water that isn't quite pristine, and it's not a pleasant experience. So, is pollution from urban surfaces a problem? That's the first question, and a question that's been asked recently by some of the stakeholders. This is some information from the Environment Agency that demonstrates that it clearly is a problem. Certainly been well known in Scotland for a long time. One of the principal drivers for using SuDS in Scotland has always been water quality, and in other countries as well. So essentially, diffuse pollution by source, 24% of that is from urban sources, and that includes residential sources as well. And what we're thinking about here for SuDS in particular, diffuse pollution is different to sort of gross pollution that you get from spillage events. This is day-to-day pollution, and that's the kind of chronic long-term pollution that causes degradation of watercourses, of the ecological quality of watercourses over time. So there is evidence that it is a problem. Can it be quantified? There are lots of questions being asked at the moment about how we design SuDS to remove pollution, and can we quantify A, the inputs into the SuDS systems, and then B, how do the SuDS systems remove it? And again, there's a lot of evidence that all types of urban surfaces contribute pollution, and there are numbers around, levels of pollution that we can use in design. My day-to-day job is a SuDS designer, and I use these numbers on a regular basis to allow us to design the treatment part of a SuDS system. And these are just some references. So Brian Ellis at Middlesex University did a paper in 2012 where he's referencing 71 separate UK studies. So I think we have got quite a robust evidence base there in terms of UK-based data to add to all the international data that's around. And 205 individual storm events that we've got water quality data for. As an engineer, that's more than enough for me. Thank you very much. There's always going to be variation. This is natural. It's influenced by so many things. We're always going to have variation. The point is that at the moment we've got to live with that variation and design around it, and we can do. I think later on I say I'm a geotechnical engineer. If you think there's variability in the pollution input into a SuDS, look at the variation in soil strength below a foundation, and yet we've been designing foundations for years and managing that variation. So this is one of the, this study is from 2001. It's one of the studies that Brian Ellis references that was done by the School of Geography up at the University of Leeds back in 2001. It's a database and recommended values for strategic planning models of urban stormwater quality. A very good tool there that we use on a regular basis. And that's just one example of there's a whole list of key pollutants in there. And event mean concentrations and pollutant loads. So that's just one for suspended solids. And if you look at that, residential, the mean value for residential surfaces is actually greater than it is for industrial commercial surfaces. So really we've just got to treat all urban surfaces as a source of diffuse pollution and design the SuDS systems for all those areas on that basis. And just some numbers here that back up what is in those reports. So at Lambdrove, the work that Fowler's been doing, the control site there, the housing, TSS of about 130 milligrams per litre, event mean concentration, which is, it's the same order of magnitude of what all these other documents have quoted. And the same for the M42 at Hopwood Park. There's an HGV parking area there. That's got higher pollution loads. So again, the TSS there as you'd expect, is higher, 429 milligrams per litre. But really, if we start looking at those runoffs from those impermeable areas, the standard for minimum impairment is 19.1 milligrams per litre. So the stuff that's running off these urban surfaces is above what we want in the watercourses. So that's why we're looking at water quality treatment in sustainable drainage systems. And what this is driving us towards, it's driving us towards a treatment train concept. So are we confident that SuDS can remove pollution? Swales, wetlands, etc. There's a website called the BMP database, which is American, but having said that, the laws of physics and the laws of chemistry don't change just because we cross the Atlantic. A lot of that data is relevant to the UK. Over 530 studies on there of pollution removal from various types of SuDS. I did a literature review for Interpave, which is the trade organisation for concrete block permeable paving. Can't remember when it was, 4 or 5 years ago. But I found 25 studies on pollution removal within permeable pavements. So there's and a lot of those studies were actually from the UK. Surrey Report C609, which was the precursor to the SuDS manual, 11 studies on pollution removal from swales. I ask you the question, can proprietary systems, can they demonstrate that level of testing on actual sites? I mean, all this testing on the SuDS is actually on installed sites. It's not theoretical lab testing. So it's a much better indicator of how things perform in reality. And again, that's just looking at suspended solids. In the BMP database, you can download all this stuff for free off the website. And that gives you an indication of the mean concentrations, various statistical analyses on that data. And without a doubt, there is variation in the performance of all these systems. But by and large, they are giving a reduction in the pollution from what's coming in to what's going out. But there's also variability in proprietary systems. Some of the manufacturers will tell you that they've got great lab testing data that shows how effective their system is. In my experience, that lab testing is targeted at one particular flow rate. It doesn't look at the variability in actual rainfall events. Again, on the BMP database, there is some actual in situ testing of proprietary systems. And lo and behold, when you look at that, the variability, there's not that much difference. It's the same order of magnitude between the green SuDS and the engineered SuDS. So why are we worrying too much about, we don't understand how these things work. We actually understand very well how these things work if we're prepared to go and find the data and analyse it. So what we're trying to achieve in the design. For water quality, Bridget's already discussed interception. Very, very important in terms of reducing the overall pollution load on watercourses, on receiving watercourses. And Bridget's already explained this, but the key thing to this is that it's preventing runoff from a development for the majority of events up to 5 millimetres. You don't have to have interception for every event. Eventually the ground will get saturated, the system will get saturated, and for some larger events you won't get that 5 mil, and that's not a problem. The philosophy is that we get the majority. So I have seen, quite frankly, what is nonsense about you can't achieve interception in London. Well, either I've dropped a bollock somewhere in some of our designs, or somebody else is wrong. And all our designs appear to be working in accordance with the designs. So you can, but you've got to think about it. And it's that thinking about, it's the majority, you're not trying to get everyone. The other thing that you need to consider is overall robustness of systems. You need redundancy. So again, it's not just about putting a swale in or a permeable pavement. They both remove pollution in different ways. And by putting a treatment train system in of a permeable pavement followed by a swale, there's a level of redundancy in there so that, for example, if you don't look after your permeable pavement, the whole system will still work and still get you that level of removal. Also, different types of system will treat different pollutants, and they'll remove pollutants in different ways. And again, the overall system will take out most of the pollution, whereas with an individual system, whether it's proprietary or for want of a better term, normal SuDS, it will be less effective. And we need to prevent re-entrainment in larger pollution events. So when we trap it, we want to make sure that it stays where it is. We don't want it all trapped there, and then when we get a big event, a big chunk of pollution getting washed into a watercourse. We've talked about that, different removal mechanisms and processes. If you concentrate flow from a big area into a very small area, which is what we tend to do with normal drainage systems, then there's obviously a greater risk of the pollution building up to toxic levels. And there's certainly a greater risk of things not working. So one of the overriding principles of SuDS and source control is to keep everything spread out. And the reason they work is because we're keeping everything spread out. So there's a lower load per unit area of SuDS in terms of silt and pollution. And that's why source control works. That's why SuDS work and why they're shown to be so effective. And this all leads us back to the concept of the treatment train, rather than depending on one individual device such as an oil separator. So which approach is best? We've done really well today, the presenters, because we're all telling you the same thing so far. It depends on the site and it depends on the constraints. And every site will be different. I think Alistair said this, Bridget said this. And a lot of sites we work on, there isn't a lot of open space. So we end up putting a lot of engineered systems in. But our starting point is always to look at what open space is available, put what SuDS we can in there. And that does depend on clients, if they want open water or not. And then work backwards from that. Because as Alistair said, digging a hole in the ground and not filling it in is a no-brainer. It's got to be the cheapest option construction-wise. And then you can minimise the amount of engineered SuDS you need around what landscaping space you've got. So this is a car park. It's in Little Eaton Recreation Ground, which is up in, I don't know if in Nottinghamshire or Derbyshire. I'll have to improve my geography. But essentially this is just a resurfacing job on a car park. Now we could have gone to town on this. We could have put rain gardens in, we could have put swales around it and things like that. But it would have meant re-engineering all the levels on the car park. There were some other issues about moving water around. So for this one, it's not actually practical to use green methods, and it's certainly not cost effective for what they were trying to achieve. So in that one, it's a resurfacing job. It's just put porous asphalt across it, job done. Yeah, and it's doing the job. At Landrove in Cambourne, which Fowler's been involved with, they've actually done some monitoring on a system. And this is a combination of engineered methods and green methods. So they've looked at the water quality and they've measured the water quality at various points within that system. So there's permeable pavements, there's filter drains, filter strips, detention basins, the whole thing. Somebody's you just pick the SuDS manual up and throw it at it, don't you? But the important thing is this monitoring data that they've been collecting. And as you can see, you probably can't see the control site very well on there. The big orange bars on that are the concentration of pollution on the control site, and the little blue ones, which you can't see, are the study site, the SuDS site. So there's clearly a lot more hydrocarbon contamination coming off the control site than there is out of the SuDS system. And that's the same, they've looked at a wide range of pollutants, and that same conclusion overall is what comes through from the whole thing. So that's BOD and COD, organic carbon and suspended solids and metals. It's all telling you the same thing, that the runoff from an urban residential site is polluted, and the SuDS is cleaning it up. And it also shows that the treatment train is effective. So these aren't in numerical order in terms of where you're going down the treatment system from 1 to 8, but the points at 3, 4 and 6 are in series down one part of the system. And if you look at 3, 4 and 6, you can see quite clearly along that treatment train that there is a progressive and significant reduction in pollution as you go down that system. So that's quite a stark indicator and evidence that the treatment train approach works. This is a chipboard factory that we designed quite a few years ago, a SuD scheme for a chipboard factory up in Northumberland. And this has been designed using the guidance in C609 on developing a treatment train, plus a little bit of research, because we did have to look at formaldehyde removal, which is it's not in the list of pollutants. So sometimes, as a designer, that it's not there on a plate for you. You have got to go somewhere else and find the information to allow you to do it. There's a bit of engineering judgment, or Steve going, yeah, that's about right. But they are natural systems. There will be variation again, and you have got to. There is an element of risk assessment in designing these treatment trains. So essentially, you can see up on the right-hand side, there's a big yard. It's full of sawdust piles, log yards, wood chippings, you name it, it's on there. The only way you can drain that is by draining it off the edge. You can't put a normal drainage system in because it will clog up. So there's a swale that runs around from stage 1, runs around the edge of the yard, shown by that light blue arrow. It then gets, because of the length of that, I think it's about 750 metres long, we're talking a big area here. You get to the end of that and we were going against the ground levels. Even though we're flowing towards the river, the ground levels are rising. So we ended up with a very deep swale and we needed another level of treatment after it. So we've had to put it into a pumping station. The sustainable option here is to put it into a pumping station because that allows us to construct a big wetland that is not very deep. Otherwise we would have had a 5-metre canyon in the ground that would have cost an absolute fortune to construct. So you've got to think about every site on its own merits. And the sumps in the pumping station are actually a treatment stage. And then it overpumps into that first stage wetland and then into the second stage wetland. And that wetland has been designed, we've got gabion walls in there with limestone in it because there's a pH buffer to act as a pH buffer in there as well as removing formaldehyde. So these are just pictures of, that's the kind of silt load that we've got to deal with on the right hand side. That's a swale. We've put armouring in there because they're going to have to clean out the sawdust very, very frequently. And in discussions with the client, they wanted that in there. I'm not sure now whether I would actually put that in these days, but it was a design decision at the time. And then once it's growing, that's what it looks like at the bottom once it's growing up. That's just pictures of construction of the wetland. It's all lined. Perversely, there's some superb sand and gravel underneath this site that is ideal infiltration country. But because of the pollution in the runoff, we're not allowed to let it soak into the ground until it's been through the treatment system. So that's why the wetland's lined. And then you can see in the bottom, that's a photograph about 4 years after it's been constructed. And you can see it's a well-developed wetland now, and it is working effectively. One of the most difficult sites we've worked on because it's actually had to, we had a discharge consent on this site that we had to work to and design to. So crucially, we had to make sure that there was less than 2 milligrams per litre formaldehyde coming out of that, which the system design achieves that. And it's monitored on a regular basis because it's got a discharge consent. And the last time I spoke to the people up on the site, they've not had any issues with meeting the compliance. We've actually had consultants who are working for the same client on other sites ringing us up to ask us how we did this. So it obviously is an effective system. This is another one in Scotland, not the one that we've designed. It's one that we went to look at when we were writing C609. So we went to look at this in 2003, but it's the same sort of system. It's a wood yard drained by swales, then through a series of ponds and into a wetland. So it's the same principle that we've used. But the interesting one about this, so you can see again, you do get massive silt loads in these systems, in the top of the system. And everybody looks at that first photograph, and you ask somebody about that first photograph, what's wrong with the swale? And everybody says, oh, it's failed. It hasn't. It's full of silt. It's doing what it should be doing. It's working perfectly. It needs cleaning out at that point probably, but there isn't a problem with it. And there's certainly no runoff getting further down the system, and then it runs down into the end of the system. But this next picture to me is better than any amount of testing. So Neil McLean at SEPA, when it was raining one day, went and took samples out of each section of that treatment train. So you can see quite clearly there that it's having an effect. But as you go down the system, the treatment train is gradually removing the silt from the runoff. And you can probably drink the end one. So conclusions, apologies for running over. Urban diffuse pollution is a problem on all sites. We know enough now to understand the design inputs, and we can design these systems, and people are doing that. There's lots of evidence on the performance of SuDS, and the treatment train is absolutely vital, and hopefully it will remain in the guidance that's going to accompany the SuDS standards. Thank you.